Hi there and welcome back to the College Physics series. In today's video, we're going to be discussing all the important ideas about projectile motion. And really what you're going to learn is that you already know everything in order to master projectile motion. Be sure to download a copy of the guided notes in the description so that way you can follow along with me in today's video. Thank you for being here. Let's get started. Have you ever wondered how a basketball arcs through the air before it hits the hoop? Or how stunt drivers calculate the perfect speed for a car jump? These are classic examples of projectile motion, where objects move in two dimensions under the influence of gravity and nothing else. So what exactly is projectile motion? A projectile is any object that moves in two dimensions under the influence of gravity alone. There's no engine pushing it forward, and we are ignoring air resistance. Here's a major idea. The motion in the horizontal and vertical directions are completely independent. You can think of projectile motion as two separate motions happening simultaneously. Let's picture this with an example. So here we have a basketball player, and this basketball player is going to shoot the basketball into the hoop. The trajectory that this basketball takes follows an arc, and in this case, it's an air ball. Regardless of whether the basketball makes it in or not, this basketball is going to be shot up with some initial velocity, and we will just call it v. So if I inspect the vector on the side, vector v, well, that's going to have an x component. So this vector is going to have speed or a velocity in the x component, in the x direction, and in the y direction. This means that for an object moving through the air, it is traveling in both the x and y directions at the exact same time. There are some important ideas when it comes to each separate motion. For a projectile, one part of its motion is going to be horizontal, and the horizontal part of the motion can be represented by uniform motion. And that means that the acceleration is equal to 0. So what that means is that we cannot use the kinematic equations of constant acceleration to describe any part of that motion. We can only use the equation of constant velocity. The second part of the motion is the vertical part. As a projectile moves through the air, the vertical piece of the motion is simply freefall. And that means that the vertical acceleration is equal to negative g. And I guess let's make this more complete. When I'm talking about the horizontal acceleration is 0. So this means gravity is going to be accelerating the object vertically at a rate of 9.8 meters per second squared. And that means that we can use the three kinematic equations of constant acceleration motion in their modified form for freefall in order to analyze the vertical part of a projectile's motion. So these are the three kinematic equations of motion in the modified version for freefall. So if we're going to be figuring out any information involving the vertical motion, these are the three key equations that we're going to use. Here's the key takeaway from all this. Gravity only affects vertical motion, not horizontal motion. Let's illustrate this with an example. Let's imagine you drop one ball straight down, let's say from this surface. So we have one ball and it's just going to be dropped straight down. And then we're also going to be rolling another ball on the surface. So we have the second ball that's going to accelerate down the ramp and then travel across the horizontal part of the table or this surface, and it's going to leave the edge with a horizontal velocity. The question is, which one hits the ground first? The answer is that they both hit the ground at the same time. We know this because the vertical motions are identical. They are both in freefall. The only difference is that the ball that rolls off is moving horizontally, but that does not change how fast it falls vertically. In the next video, we're going to be analyzing similar examples, but we're going to be completing the entire problem-solving process. For now, we're focusing on answering questions using the concepts. Now let's break down how we can analyze projectile motion using some physics that we've learned already. We're going to establish a coordinate system with the x-axis being horizontal and the y-axis being vertical. Let's say we toss a basketball at an initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Whenever you encounter a projectile motion problem, you are going to be initially breaking down the velocity into components. So this basketball has an initial velocity in both the vertical and the horizontal directions. If I complete the right triangle here, my angle is towards the left. That means that the x component is going to be the magnitude of the vector times the cosine of the angle. And the vertical component is just going to be the magnitude of the vector times the sine of the angle. To plug in the numbers, we're going to get 20 meters per second for the magnitude times the cosine of 30. That'll give us an answer of 17.32 meters per second. For the vertical, we're going to get 20 meters per second multiplied by the sine of 30, and we're going to get 10 meters per second. So remember, this initial vertical velocity is going to be the initial velocity from a free fall perspective, and the horizontal velocity is going to remain constant during the entire motion. This will be how you begin most projectile motion problems. In vertical motion, redo. In free fall, gravity constantly pulls the object down, changing its velocity at a constant rate over time. Let's draw a picture. This is going to represent the ground. So this would represent a path for a projectile. Let's say this is where the projectile was launched off from. That's the start, and we will consider our ending point. Let's say it has an initial velocity of 29.4 meters per second to begin with. Vertically, it's going to have this initial velocity, and horizontally, it's going to have this. As the projectile rises, that velocity is going to be decreasing by 9.8 meters per second every second. By the time it gets to the next second, this vertical velocity is going to be 9.8 less. So here it's going to be 19.6 meters per second, while the horizontal velocity remains constant. Another second later, it's going to decrease by another 9.8. And so at this third second later, it will have a vertical velocity of 9.8 meters per second, and the horizontal velocity is going to remain constant. At the very peak, the vertical velocity is 0, and at the peak, the only velocity is horizontal. Let's jot this down. Vertical velocity is 0 at the peak. When it starts to fall back down, gravity is still accelerating it at the same rate. So 1 second later, it's going to have a vertical velocity of negative 9.8 meters per second, and it's still going to have the same horizontal velocity. The next second later, it's going to gain another 9.8. So here it'll be negative 19.6 meters per second, while horizontally it will have the same. And then finally, at this end point of the motion, it's still going to gain another 9.8, and it'll be negative 29.4 meters per second. And horizontally, it's still going to have the same velocity. Notice that an object that is in projectile motion, when it reaches the same position before the peak and after the peak, those velocities are equal and opposite. That's why these two are the same, equal and opposite. 9.8 is still the same as 9.8, but negative on the right-hand side. And at the peak, it's just 0. These are the important concepts that you need to understand about combining free fall with constant horizontal velocity. So the key takeaways from today's lesson are: 1. Horizontal and vertical motions in projectile motion are independent of one another. 2. The horizontal motion is uniform while the vertical motion is free fall. And 3. Understanding how to break velocity into components is essential for solving projectile problems. Before we end today's video, here is a try-it-yourself problem. The try-it-yourself problem reads: a marble of mass m1 rolls off a table 1 meter from the base of the table. A second marble of mass 2m1 rolls off with the same speed. How far does the second marble land from the base of the table? And here's an extra question: how will your answer change if the second marble rolled off with twice the speed? So that will wrap up today's lesson on projectile motion. Remember that mastering projectile motion just requires practice and a clear understanding of these concepts. If you found this video helpful, don't forget to like, share, and subscribe for more physics lessons. Thank you for being a part of the College Physics series. I will see you in the next lesson.